Now we are moving on to our last technical session focused on the theme Sustainable Environment for Healthy Living. Before we commence with the presentations, it's my honor to introduce our esteemed session chair, Mrs. Sardani Dias, who will be guiding us through the fourth technical session. Mrs. Sardani Dias serves as an environmental consultant in water resources management for development projects. Her academic journey includes a postgraduate diploma in environmental science and technology from the International Institute for Hydraulic and Environmental Engineering, a Master of Science degree in environmental science and technology from the International Institute for Hydraulic and Environmental Engineering. Further, Mrs. Dias is a former Directress of Environmental Studies and Services Division of NBRO. Now, I would like to invite our esteemed session chair, Mrs. Sardani Dias, to join us at the head table. I'll now hand over the session to you, madam.
Thank you. Thank you for the kind introduction about me. Good evening to all of you. So we are coming here for the last session. I kindly invite the presenters. I think all are from the Environmental Division. Mr. Chandrasena, Mr. Sumanasekara, and Mr. Jayasena, and Mr. Ruhunuge. Please take your seats in the front desk. Okay, now here we have got very important topics. Here I have seen where environment subject has sort of integrated into the domain of disaster management, which is a really important situation. Now the risk and disaster in the context, like the environment subjects have been sort of discussed. So we have very good 4 topics. So the first topic, to present your research outcome, let me kindly invite Mr. Chandrasena to speak on the topic of development of an early warning tool for instantaneous chemical spillages into flowing water bodies. This is a subject on chemical disaster risk assessment.
Good evening, everyone. I am Kastunalim from Environmental Division. So my topic is development of a risk assessment tool to instantaneous chemical sprays to flowing water bodies. So before moving to heart of my presentation, I would like to give you a solid understanding about the story behind my work. So as you all know, chemical disasters are becoming more frequent in current days due to rapid industrialization in the world. Due to that, such events and results fires, explosions, and spills, and releases of hazardous materials to the environment. So, especially waterways nearby factories, railways, and highways can be affected by hazardous chemical spills. So, such chemical spills to the waterway results contamination of water, harm to aquatic life, and also disruption of ecosystems, and human health risks and economic impacts. So if I get to the Sri Lankan context, you can see there are so many recorded incidents in Sri Lanka. For an example, as you all know, the Canal River diesel pollution, a very famous incident, and also diesel leak at the Nilwala Ganga, and also fuel browser crashes into Battulu incidents. Such kind of incidents were there. The special thing is all these accidents are incidental chemical releases into water bodies. That's an accidentally released chemicals. So if I remind the pollution incident in the Canal River, you all know that on 17th August of 2015, a very famous beverage factory in the Biagam area released diesel to Canal River. So due to that, the contaminated the Ambatale water intake. You can see where is the beverage factory and the Ambatale water intake. the distance between two points are nearly 4.5 kilometers. Likewise, due to that accident, the polluted the water supply for millions of Sri Lankans in the Colombo district. You can see the oil plume in the Kalni River, the black color dots in the water surface, and also contamination at the Ambutale water intake. Due to that, the government incurred huge cost to clean up this river. They have to pay a lot of cost to cleaning process. And chemical spills severity depend on what are the factors. Type of chemical, quantity of spill material, and the location of spill, and speed and efficiency of response. Let's consider type of chemical. We can't control it. And also quantity of spill material. We can't control. Location of the spill, also we can't control. Only thing we can control is the speed and efficiency response. We can, if we can support to speed and to efficiency response, that will be beneficial for managing such kind of bad impacts. So, mode of pollutant transport and mixing. So, if I get the theoretical background of my work, mode of transport can be divided into two parts. It is a diffusion and advection. Diffusion can be divided to molecular diffusion and the turbulent diffusion. Based on that, the scientist has renovated the very differential equation to achieve differential equation to capture that incident. That means the time rate of change of mass within the control volume is equal to the advection influx into the control volume and the diffusion flux into the control volume, and consider the reaction and source and links. So, for solving this differential equation, they have simplified the equation like that. So, this equation can be used to predict the concentration at the flowing water body. The x, y, z direction are showing that graph. You can get some rough idea about the what are the notation of that equation. So, what are, yes, let's consider the incident. So, when there is a chemical release, there is a mixing zone. After that, the concentration is considered as a simultaneously spread. So, if we look into the mixing zone, let's consider the first point. At the chemical release point, the concentration is very high and the spread area is very low. But when we go to the downstream of the water body, the concentration will be decreased and also spread area will be increased. Likewise, the dispersion will be occurred. So, we can use the following three equations to determine the concentration at flowing water body. So, that means C1, C2 and C3. What are the M1 means the chemical mass, and T is the time after the chemical spill, and also D the river depth, and the A is the cross-sectional area. Likewise, we can use these three equations to predict the concentration at the flowing water body. So, this is our tool in build process. So, we have used these previously mentioned three equations to our tool. So, what are the inputs? Input is mass, quantity of spill mass, and the mean flow rate, and the average river width, average river depth, and also river bed slopes. So, when we input these details to our tool, it automatically select what is the equation and plot our graph. So, this is the data input interface of our tool, and also this is the output graph. I will briefly describe how to get the critical information through that graph. This is a tool demonstration. Let's consider there's a chemical release, and at the early stage the chemical concentration is very high. Likewise, when we go through the flowing direction, the concentration will reduce likewise. So, let's consider the x1 distance. When we consider the x1 distance, our tool output graph shows the chemical concentration is about 4. But when we move to the x2, the concentration level is reduced, but the distance is increased. Likewise, we can predict the distance versus chemical concentration in the river body. So that concept we use to our tool. So hidden information in the graph. So let's consider graph number 1. Contaminant concentration versus distance at a fixed time. That means we fix the time and plot the concentration versus distance. That means according to first figure, it shows the graph shows the chemical concentration after 2.5 hours from the release. According to that, we can get the plume goes nearly 4.5 kilometers within that 2.5 hours. Likewise, if we consider the second graph, that is we fix the distance and plot the concentration versus time. Accordingly, we can get some rough idea about the behavior of that chemical plume in the flowing water body. So this type of information are very critical for early warning purposes. So if I conclude my presentation, this tool can be used to predict chemical concentration in the flowing water bodies, and also tool is very user friendly and gives quick results, and also accuracy of the tool highly depend on the water body characteristic, and also this tool can be used for administrative decision making and emergency response planning, and also infrastructure development and environmental protection and regulatory compliance, and also policy development. So these are the references, and thank you all.
The importance of tree risk and management in urban environment.
Good evening to all. I am present importance of the tree risk assessment and management in urban environment. Urban trees are an important component of urban greening, and they provide many economic, social and environmental benefits to the urban environment as well as well-being of the residents. And however, there is a risk, there is a potential risk associated with trees. This leads to disastrous consequences such as property damage, personal injury, or loss of human life. And you all were from newspapers and public media in last 3 months. There were tragic incident happened in Sri Lanka because of the tree falling. Results of that, there is a loss of lives and injuries, and also damage to properties. That increase the public attention on tree failures and create a timely needs and urgency to have a proper tree management in Sri Lanka. Several factors can contribute to a tree's potential to fail or cause damage, such as tree health, public physical conditions of the trees, and extreme weather conditions, and improper plantation activities, construction activities, and root system failures. Tree risk assessment is crucial for identifying potential hazard posed by trees and ensuring the safety of people and property by implementing proper mitigation measures. When we consider the global scenario, the tree risk assessment are done by the dedicated individual with specialized training using the systematic and advanced tree risk assessment techniques. In Sri Lankan context, there are designated institutes available to manage and maintain the urban trees. But there is a challenge regarding the systematic and consistent implementation of the tree risk assessment. Additionally, there is a lack of expert in the field of tree risk assessment. Similarly, field research has been done, and there is a research gap. As a technical institute of disaster management division under the Ministry of Defense, NBRO have to develop its capacity on tree risk assessment. Accordingly, we have developed a research with the following objectives. The main objective is to develop the tree risk assessment guideline And also there are 3 specific objectives. First one is develop a tree risk assessment form. Second one is develop NBRO capacity on tree risk assessment and management. Third one is develop and maintain an inventory of trees for urban tree risk management. When you consider the procedure, first we did the literature survey by referring to the international publications and international journal, and then we developed the tree risk assessment form under the guidance of the expert in National Botanical Garden. For develop that form, we consider the 28 factors that was the tree consider the tree health, and also we did the rapid tree assessment in selected areas in Colombo by using 2 techniques. Those are visual assessment technique and basic assessment technique. And also we organized the 2 training programs to enhance the capacity of NBRO staff. The first one is organized at National Botanical Garden, Peradeniya, as a preliminary tree risk assessment training. And second one is organized at the University of Jayawardhanapura. It's based on field techniques and the urban tree care and management. Then after the data collection, we categorize the risks of each trees by using risk assessment matrix. And then by using those results, we develop the risk assessment guideline, and also we develop the risk assessment inventory. But our ultimate target of this project is to provide the service on urban tree assessment to the general public. I will show here the common defects we can consider to measure the tree health. Those are codominant stems and epiphytes and fungi grown on the trees, and cross branches, invasion of other plants, grade changes, poor taper or lean towards the target, human caused defects, cavities, root failures, decay and hanging and dead branches, improper pruning, and also termite colony attack to the plant. Then the data used to risk categorization. Then for risk categorization, we use the evaluation matrix. In here, we consider the 2 factors. Those are tree health and risk status of potential target. When we consider the tree health, the data were evaluated according to the 10 criteria. Those are structural conditions, pest attack, wind exposure, cavities, so on. And likewise, risk status of potential target, we also evaluated according to the, under 4 categories. Those are target zone, occupancy rates, practical to move target, and restricted practical. And finally, those criteria give the point scoring system to categorize the subcategory. In the tree health, we categorize into 4 categories according to the accumulated point. And also, those are low, moderate, fair and good. And also risk status of potential target categorized into 3 categories according to the accumulated point. These are high, moderate and low. By using these results of the evaluation matrix, our team developed the risk assessment guideline. This is the risk assessment guideline. As I said earlier, we used the 2 factors, tree health and risk status of potential target. We can use this guideline to assess the level of risk in any plant. When we take an example, the tree is the tree health is under low category, and there is status of potential target under high. If then we can categorize that tree in extreme risk level. Likewise, we can use the risk assessment guideline to assess the risk level of each trees. This is the output of our survey. We assess 48 trees in our survey. Out of 48, 4 trees categorized into low risk category, and 10 trees categorized moderate risk, 21 categorized high risk, and also 13 categorized as extreme risk. This is the other output of our survey. We developed the inventory including the general details of the tree, details of the tree health and potential target details, and also level of risk and mitigation action. We can use this inventory for risks of hazardous trees, early warning for risks of hazardous trees in future. In way forward plan, the NBRO expect to provide tree risk assessment and identification service to the general public on their request, and offer tree risk assessment training to the relevant institute and those who are responsible for urban tree management. And conclusion of our survey, the developed guideline can be used to identify hazardous trees and their level of risk in urban areas. And thank you very much.
Thank you, Imuthi. It's a very timely subject you have spoken with a lot of uncertainty. So questions will yet to come. We'll ask the question in the end of the session. The next presenter is Mrs. Dilhara Jayasena. She will be speaking on the assessment of risks associated with the air pollution in urban areas of Sri Lanka.
Good evening, all of you. I'm Dilhara Jayasena from Environmental Studies and Services Division. My topic is assessment of risk associated with air pollution in urban areas of Sri Lanka. Rapid urbanization and industrialization cause air pollution, which leads to increased health risks, climate change, global warming, and etc. World data indicate that developing countries, mainly South Asian countries, are the victims of air pollution. When we talk about South Asian countries, Lahore, Pakistan, Bhiwadi and New Delhi, India, and Dhaka, Bangladesh were identified as the highest pollution ranking cities worldwide. Colombo was on the list in early 2009, but now it's in 54th place in world rankings. It's due to, after 2009, there was a slight decrease in air pollution in our country. When we talk about air pollution related health risk in Sri Lanka, leading causes for hospitalization early 1996. Lower respiratory infections have been reported as the second highest cause of hospitalization in Sri Lanka early 1996. Leading causes for hospital deaths in 2020, its fourth highest cause happened due to ambient air pollution on respiratory systems. When we talk about health-related sustainable development goals, mortality rate attributed to household and ambient air pollution is happened 5th highest rank. Ambient air pollution act as a silent killer. Why is that? Because it's not visible, and anything can happen anywhere. Therefore, continuous monitoring and attention is highly important with a sudden increase in air pollution on certain days. Accordingly, NBRO has started a real-time monitoring program in urban areas of Sri Lanka. Evaluation should be carried out with current air quality levels and regulatory standards. In this study, we present the risk of air pollution levels and rank each selected urban city with current trends. The objective, monitoring continuous air quality data in urban areas of Sri Lanka and ranking each area based on guidelines, norms and regulations. The first one, WHO guidelines. The least value is 5 microgram per cubic meter, and there are some interim targets too. The second one, National Ambient Air Quality Standards. The least value is annually 25 microgram per cubic meter. The third one is United States Air Quality Index. There are 6 levels as good, moderate, unhealthy for sensitive groups, unhealthy level, very unhealthy, and hazardous. For my study, I used unhealthy level for air quality index. When we selecting the study area due to factors affecting air pollution, first we are talking local sources, vehicular emissions, waste and biomass burning, emissions from industries, petroleum refining and power generations, domestic activities such as smoking and firewood burning, agricultural activities byproducts, and mainly the external sources transboundary effect due to air pollution of neighboring countries. According to these factors, 17 urban areas were selected by covering the whole country for this real-time air quality monitoring program, mainly considering the effect of transboundary pollution and distribution of other pollutant sources in each area. The methodology, real-time air quality levels with respect to PM 2.5 were collected within selected urban areas in 2022. Measurements were taken using validated light scattering sensors incorporated into the IoT platform. The collected data were analyzed based on WHO guidelines, National Ambient Air Quality Standards, and US Air Quality Index. Ranks were given to each urban area based on the number of days exceeding the WHO guidelines, National Ambient Air Quality Standards, and unhealthy level of US Air Quality Index in 2022. Final ranks were confirmed by considering the unhealthy level of US Air Quality Index in 2022. This is the systematic architecture design for real-time air quality monitoring. The results based on first WHO guidelines and National Ambient Air Quality Standards, we selected some urban areas as most risk, highly polluted areas. The results based on WHO guidelines, in Jaffna, 27% of days were within the limits. In Badulla, 32% of days within the limits. In Colombo, only 33% of days within the limits. And finally, Puttalam, 24% of days within the limits. And all the days in the year 2022 were exceeded the levels. The results based on National Ambient Air Quality Standards, in Colombo, 5% of days were exceeded the limits of National Ambient Air Quality Standards. In Badulla, 8% of days were exceeded the limits. In Puttalam, 6% of days were exceeded the limit. And in Jaffna, 11% of days were exceeded the limits in 2022. Results based on US Air Quality Index. First, in Jaffna, 6% of days were exceeded the limits of unhealthy level of US AQI. Badulla, 3% of days were exceeded the unhealthy level. And also Colombo, 4% of days exceeded the unhealthy level. And finally, Puttalam, 3% of days exceeded the unhealthy level. According to all these data, ranks of urban areas were given by based on the number of days exceeding the National Ambient Air Quality Standard in 2022 according to this. Based on the number of days exceeding the unhealthy level of US AQI in 2022, like this. And finally, according to the data gathered from each urban area, Colombo, Badulla, Puttalam and Jaffna can be ranked as the first, second, third and fourth most polluted urban areas in Sri Lanka. And Nuwara and Kalutara can be ranked as the least polluted urban areas based on the National Ambient Air Quality Standards. Jaffna, Badulla, Colombo and Puttalam can be ranked as the first, second, third and fourth most polluted urban areas in Sri Lanka. And Nuwara and Ratnapura can be ranked as the least polluted urban areas based on the unhealthy level of US Air Quality Index. Health risk is mainly focused on the unhealthy level of United States Air Quality Index because it is the main health-related guideline, and the final ranks were given by considering the exceeding days of unhealthy level in US AQI. These ranks may be changed with the time considering the urban factors and by year-to-year meteorological conditions. According to health point of view, Jaffna is the most polluted urban area in 2022 due to the high risk of unhealthy levels during a long period of days in the year 2022. As the future direction and way forward, identification of pollutant sources and their contribution in each city, forecasting of pollutant levels for early identification of risk levels and public awareness, and development of city-wise management policies and strategies based on the local environmental conditions should be carried out. These are my references. Thank you.
Thank you, Dilhara. We'll ask some questions in the end of the presentation. So next presentation is again a very important topic where we can link the Internet of Things, the remote monitoring technology to the disaster risk assessment. So let me invite Mr. Ruhunuge, Scientist, Environmental Division, to present.
Good evening, ladies and gentlemen. So my research topic is integrating Internet of Things technology for effective environmental monitoring. Let's move on to the presentation. So what are the most discussing topics nowadays in Sri Lanka? So these are the topics like bad air quality, bad water quality, resilient community, sustainable agriculture, and disasters. Since morning, we listened a lot of discussions, presentation related to these topics. We are working as a scientist in each sector, either one sector or two sectors, and so on. So as a scientist, what is the common question we have? Data. Lack of data. This is the main question. So without data, within the research, we have done some interpretations, conclusion. Can we have enough reliability on our interpretation and the conclusion without consistent data? So to have such kind of reliability, we have to have consistent, reliable, cost-effective, and real-time data collection approach and strategy. To this kind of strategy, we have some kind of sophisticated instrumentations. But with this kind of instrumentation, we cannot deploy this kind of instrumentation at once in different areas simultaneously. So because of the cost and the maintenance cost and the operation cost. Then what is the solution we have? IoT-based microsensors, otherwise low-cost sensors. Why these low-cost sensors are not so much popular
nowadays in Sri Lanka, but little bit popular in the other part of the world. But in Sri Lanka, it's not so much popular because of these attached questions: accuracy, sensitivity, linearity, performance verification criteria, and calibration. This is the most 5 important parameters attached with our low-cost sensors. Most of them are questioning, especially calibrations. So I would like to share something in Sinhala, like good things are never cheap and cheap things are never good, like laba baduwe hila. That's the concept. So we think these are not suitable for the monitoring, but in the national level authorities and some kind of organizations like EPA already recognize that these low-cost sensors can be recommended for non-regulatory, supplementary and informational monitoring. This is recommended. Not for the regulatory monitoring, but for the informational monitoring. They have defined 2 types of criteria, like base testing and the field testing. Base testing means we have to create an artificial environment to evaluate the performance of low-cost sensor. That is little bit, practically impossible in our scenarios. So creating an artificial environment, it's a cost, very cost. Then we have another solution, field testing. By using the normal environmental condition, we can verify our performance of each sensors. So within the guideline, they have defined 5 parameters to performance evaluations: precision, error, bias, linearity, and metrological effect. This table shows the relevant matrix values. That means this is the regulatory limit. If we evaluate the performance of our sensors, fabricated sensor, we should comply these target values. Otherwise, we cannot deploy our sensors for the environmental monitoring. So with these 2 documents, you can see here EPA guideline, and they have produced a technical document for the particulate matter determination by using microsensors. So practically, we cannot perform every item mentioned in this document. So what we have to do, we extract most important thing to our document and we try to perform as much as possible. Otherwise, we cannot perform. That is practically impossible. But we have to amend these things and we have to extract most important things into our documents. What we have done so far with the microsensors, we have done several research and investigation using microsensors. Soil moisture variation in hydroecological zones. In a small tank in Sri Lanka, we have done very good research to identify the moisture variation of the soil in the small tanks, especially the irrigated tanks. And the rainwater quality assessment in rooftop rainwater harvesting system. We developed our rainwater harvesting system and design. We embedded some kind of pH, conductivity and TDS sensor with the water level sensor. So we use this kind of things with using IoT sensors. Real-time map air quality in urban area. You can see, if you can browse our website, hosted under NBRO official website, you can find real-time map like this, the top corner. And we issue daily air quality report based on the value observed from the real-time air quality sensor network. And we have already drafted guideline for the performance verification of sensors. As I mentioned earlier, I showed you 2 documents published by EPA. Based on that document, we extracted important things and we developed our own guideline. This is the few pages I have shown here, like terms and conditions, how we do the base testing and the field testing, what are the testing criteria, and flow diagram of the verification, and these are the calculation. It is more than 22-page document guideline. We have already drafted and we have completed. Now we have to fine-tune this document with the expert inputs. Where are we heading with low-cost sensors and the microsensors? strengthening local sensor network. We have already AQ monitoring network. We are going to strengthening it. Under the World Bank project, we have already awarded. Under the World Bank project, we hope to upgrade our air quality monitoring network with the 100 units, another 100 units. So we can have 120 units for our air quality sensor network. That is very good approach, because having that kind of amount, we can get very good quality data and the representative data around Sri Lanka. The performance evaluation and the documentation, we are in the process of this kind of thing, because everyone are questioning the quality of the produced results, quality of our sensor network. So we can have this kind of standard documentation, then we can produce our results in an accurate level. Sensor collocation, after installation of this kind of sensors at the field, we cannot leave them forever. We have to have some kind of regular evaluation process. That is the scientific term we are using for that evaluation process, sensor collocation. Air quality forecasting, I will explain a little bit detail in next slides. Sustainable agriculture through the soil management, greenhouse gas emission and removal estimation. So these kind of thing we can do using microsensors or local sensors. Air quality forecasting platform. We try to develop a short-term air quality forecasting. Especially, I would like to say this is short-term, not a long-term. For the as a first step, we are trying to develop the air quality forecasting using persistent forecasting technique. That means next 24 hours, we try to forecast by looking today. That is the first step. After the integrating and after upgrading our network, we can have a lot of diverse data around the country. So we have very rich database. Then we can go for the criteria and the regression forecasting by using these observed data from the network. When compared with the criteria and regression, the persistent forecasting has very low accuracy, but both criteria and regression have very good accuracy for the next 2 to 3 days. It's very important. Sustainable agriculture and soil management, that is a very good topic. We are talking and we are discussing in relevant different platforms. So for the nutrient management and avoid over fertilization, the most of the farmer doesn't have enough idea how much nutrient in the soil. What they do is they apply again and again this fertilizer onto the ground without knowing the exact amount of soil. So we can try to integrate this kind of IoT things to determine the elemental level. Irrigated water management and soil moisture management and water preservation, these are very important parameters, important two topics, because now we are facing a huge problem for the irrigated water, for the cultivation. So we need to preserve this water for our future sake. Crop management, based on these parameters like nutrient, and we can identify most suitable crop during the cycle by using this kind of techniques. Farmer real-time information system, like we can have some kind of information platform directly goes to the farmer. And thank you very much listening to my presentation and being here with us. And it doesn't matter where local sensor is applied for monitoring, but it should be quality control, otherwise no use of local sensors. Thank you very much.
Thank you, Rohan, for a very informative, very timely needed presentation on this one. So while keeping this forum open for the audience to ask questions, to keep the time saved, I'll start asking some questions very important of this very important subject matter. First, my question goes to me, Kasturi. I think you have taken a dispersion and a velocity model. You haven't considered the decay component and like basically you have taken here the oil dispersion or the complete mixed situation. Complete mixed situation, okay. You don't have a mic to speak, like why don't you have a mic to speak others? Yeah, I think this is very important. Where Kasturi, you can use this one because we have a lot of water intakes in the river, our river sections, and in case, and also upstream we have a lot of industries. So this is a simple model, I think, very simple model. Any mathematician with simple mathematical knowledge and engineer can really use this one. I think it has been developed by you using the basic data on dilution models and everything. Is it?
Yes,
I
madam.
think yes. Yeah, I think anyone can use this one. Very important because so important that everybody should know how to use this simple methodology to predict the disasters. This is very important. So I think, can you present how you can use this one, especially considering the water intakes of Sri Lanka? We have many, and upstream we have a lot of industries. Can you sort of elaborate a little bit on that?
Yes, madam. So if we consider water intake, for example, I will get the Ambatale water intake also. So upstream of the Ambatale water intake is a highly industrialized area. So if we can input our tool to what is the distance and for a hypothetical incident, how much time taken to that pollutant takes time to reach to the Ambatale water intake. Likewise, when we calculate the distance and the time, we can use that data for our infrastructure development, like what is the maximum distance should have when we designing industrial area, what is the minimum distance should have for water intake. Likewise, we can use that simple, this equation are already developed equation, madam. So what I did, I used those collection of equation and use in the user-friendly manner to get result quickly.
Yeah. The other way around, you can think of there are already industries. In case of certain loads of pollution released to the environment, how long it will take to the to come to the intakes and the concentration because you are using dispersion, and also how much time you should need to get early preparedness. So I think it's a very important point. It's a very timely needed research, and I congratulate. Thank you.
Thank you.
The second question goes to, I think, Vimukti. Vimukti, I think it's also a very important subject to have spoken. This is the same problem as has come about 30 years ago when I was a very junior scientist. The Bullas Road trees were to be removed because of disaster risk. So we were at that time very conservative. We never wanted to cut down those things. Now time has come. Those trees are more than around 100 years old to my knowledge. Now risk assessment is very important, but other factors you have considered only the tree inherent factors, but there are, I think there are other factors such as the load that would transfer to the ground and the water table fluctuations, soil conditions, and the dispersion of various loads like a certain very important geotechnical aspects. I think should be integrated into this one because now there's a climate change problem.
The other one is we go to the close to the tree with the tape, measuring tape or binocular, and using that we identify what are the defects. Then other method is advanced method. In Sri Lanka, I think there's no enough advanced method. For example, there's a method, sonic chromographic method. That method used to analyze the internal factors of trees. So in this research, we applied that basic techniques. That's why we consider the simple factors. But I know there's a GPR techniques and other techniques have our other dimension like landslide division, and in future we can apply we can support them and we can apply and improve this research.
I think these are very valuable trees. around 100 years old. First thing is to how to conserve, and then the last thing one will be to remove them in case if there are no other options. Okay, thank you very much, Vimukti, for a very important presentation. And I think next question goes to Dilhara. Dilhara, yeah, I've seen that your highest pollution comes from Jaffna. Yeah, if I'm correct, like the pollution loads come from Jaffna?
Yes.
Yeah, Jaffna. And there are cities, of course, you have high this thing, and Nuwara, Kandy and Ratnapura has low concentration.
Yes.
So can you kindly
According
explain?
to 2022,
Yeah.
the year
Yeah,
2022,
or whatever it
there
is like.
were, actually there were high pollution ranking in transboundary because of the transboundary pollution. That is the main reason the Jaffna rank as the high polluted city.
Yeah. Other areas, Nuwara and Kandy and I think Badulla have low concentrations?
Nuwara and Ratnapura are
Ratnapura low.
Yes.
Okay. That means that because they are less developed, the emission sources are low
Yeah.
compared to others.
They are
Okay.
comparing the local sources and other transboundary effect, it's low.
Yet it is considered that still we are in relatively safer level with little pollution or whatever. What is your kind?
About Nuwara?
No, as a whole, the country has less number of days as a percentage compared to the entire year. Are we at the risk level? What is the situation?
Our research was on 2022. After that, we have to
really
calculate
evaluate
the
and
data
see. Okay, like what I really would like to ask this question from you, like we can monitor and can do nothing and wait and see. Or if we have a problem, if it is on the rise, okay, it is highly timely that we take some action because only few people have the air conditioning and things like that. That can filter some particles. And also we have the very bad experience due to COVID time, wearing always these masks. So I think this is a very important thing, real-time monitoring, how it can integrate into real risk assessment and disaster management, environmental pollutions. On a subject of environmental pollution, I think you all will be sort of going ahead.
Continuous
monitoring and of course the legal aspects we will not be able to do. There are the institutions, but I think you can really take this message into the upper level because it is alarming because transboundary things are there. You can't control it much, but this is a very important subject because air pollution is a real problem, another disaster, silent disaster.
Yes.
Yeah, my last question goes to, I think, Ruan. It's really important. You have covered everything, the data reliability, because every time when institutions like us, countries like us present data in international forums, they always come up with the reliability, how reliable, our data and results are always challenged. So here you have sort of presented a very nice framework to make the reliable data, number one. The IoTs are very important because I can see like how it can nicely integrate it into the Sendai framework and the SDG goals. They are very important stuff because without real-time data, you can't do much. I'll go to the first one, like you have used this one, the moisture detection. For the drought assessment. Although now last years we had very good rain, we have now completely forgotten about the droughts, but drought is a very important subject you can speak. So do you have any plans to go ahead with the drought assessment because we have about 30,000 cascade reservoirs, or basically tanks in Sri Lanka? This is a very important, the moisture is the number one to see there's a upcoming drought. So can you sort of explain it a little bit? So what are your plans? Do you have any plans or what you can do on this one?
Yes, ma'am, because the soil moisture is very important parameter for any kind of aspects. So like agriculture, for the water preservation and everything, it's very important. So in year 2018, we have conducted, 2018 and 2019, we have conducted research related to the small tank ecosystem. So we try to develop a rehabilitation guideline. So because based on that, we come up with that kind of innovative solution because we had some kind of only 1 or 2 reference meters, so we cannot measure every location at once. So we came up with that solution. So in future, we try to, we need to validate our research findings. So we cannot validate using only 1 or 2 cascade systems. So we need to have some kind of larger area for the at least 5 to 10 cascade systems. So we try to next time or some, if there is a funding available, we try to integrate and we try to continue this research to identify, because now already we have submitted several proposals to for the soil moisture management, not relevant to the small tank rehabilitation works, but we try to incorporate these things to the farming sector. So that is very important for the water preservation. So in near future, we try to embed the system to these kind of things. Thank you very much.
Now the session is open for the audience to ask. If you all have any questions, please take this time to ask.
The pollution level dropped or something like that. So it was not clear for me. And my question is, so what could be the reason?
There were some projects started from 2009, just like vehicular emission reduction program and traffic congestion reduction program like that. That is why our air pollution was reduced.
Dr. Asiri, can you say something about this tree risk assessment, the geotechnical aspect, the importance of that one for everyone's knowledge?
Yeah, I mean, it is important, of course. I think what they have done only for the visual assessment, but the groundwater level and the soil moisture saturation is very important, because as we know, once the soil gets saturated, shear strength decreases, as well as then the friction between the roots and the soil get decreased. So those aspects has to be considered, and we are working on that one. Yeah. But basically this is just started, and so we try to develop this one because we have the technology. We can check the soil strength and the shear strength of the material, because we did the research for the landslide areas, how the vegetation stabilizes the slopes. So basic concept what we study when the root penetration and the root suction, how improve the slope stability. So likewise, we can do the same assessment for the tree stability, and we will follow in that one. Thank you for your advice. Yeah.
Thank you very much, Dr. Asiri. I think with that, the 4 presentations show the hidden pool of knowledge that is really needed for the timely needed subject for the disaster risk assessment and management. So I congratulate for all my former young colleagues for your development and your innovative research. Thank you very much.
Thank you to our session chair, Mrs. Sardani Dias, for your exceptional leadership and guidance throughout the technical session, and the presenters on the job well done. Now, I kindly invite Mrs. Sardani Dias to join us on stage to present the certificates of appreciation to the presenters. Presenters, as your names are called, please come forward to accept your certificate. Mr. W.K.N. Chandrasena, Mr. V.D.W. Sumanasekara, Miss J.M.M.D. Jayasena, Mr. Ruan Ruhunuge. Before we conclude, I would like to invite our session chair, Mrs. Sardani Dias, to remain on stage for a brief moment, and I would like to invite Mr. H.D.S. Premasiri, Director of Environmental Studies and Services Division, to present the token of appreciation to Mrs. Sardani Dias for her exceptional leadership throughout the session. Thank you. Once again, thank you to our presenters and our session chairs for their invaluable contributions.